In this video, I'll explain how to graph by hand and with a calculator quadratic word problems, how to interpret them, and how to solve them using the quadratic formula, the Vertex formula, and factoring. So let's get started. The first problem, this is a model of a rocket, and it is launched from the roof of a building. Here's its flight path modeled by the equation where h represents height and t represents time in seconds after the launch. First, I'm going to graph it on my calculator. So here's the graph. You'll notice some important points. First off, here's the vertex, the maximum height of the rocket. Here are the two x-intercepts, and here is the y-intercept. So let's interpret those. The x-intercepts represent show the height at 0 meters off the ground, and it's at negative 0.3 seconds and 6.2 seconds. And the negative is not possible to have a negative time, so you just look at the positive time. The y-intercept shows that the height is 10 meters off the ground at 0 seconds. Since the rocket is launched from the roof, we can assume that that is the height of the roof. It's at 10 meters. The vertex then is the maximum height of the rocket at 55 meters, and this is at 3 seconds. The next question, a Nerf gun bullet is shot upwards off a ridge. Here's the path. H represents height again, T represents time after the bullet was shot. We're going to find the y-intercept by hand, so that's when x is equal to 0. Substitute 0 into the equation for x and solve for y, you'll get 4. When you substitute 0 in for y, you'll get the x-intercepts, and this is where you either want to use the quadratic formula or factoring, or you could even graph it to help you find the x-intercepts. So what I did is I did factoring. I removed the highest common factor, and then I factored the quadratic trinomial when a is not 1. Then it led me to 4-term factoring, and then I used the zero product property to set each of those brackets equal to 0 and solve. So I got my two t values, which t represents x in this problem. The same question, now I'm going to find the height of the bullet at 0.5 seconds by hand. So I'm going to substitute 0.5 in place of x, or in this instance, x represents my t, my time, and I get 4.5. So the height is 4.5 meters off the ground at half a second. I'm going to do the same. This time I'm going to solve for the height of 4 meters by hand, and I want to know what time. And so this is where I'm going to use factoring, and I'm going to set y equal to 4, the height, and solve for t. So I want this to be equal to 0, so I have to subtract 4 from both sides, so it's equal to 0 on the right-hand side. Then I'm going to remove the highest common factor, and then I'm going to set each of those expressions equal to 0 and solve. So I get 0 and 3/5. So the bullet is at a height of 4 meters at 0 seconds and at 3/5 of a second. Next question, this is a basketball being shot, and I'm going to find the y-intercept by hand again. So set x equal to 0, solve. And then I'm going to find the x-intercepts. This time I'm going to use the quadratic formula, and I'm going to write my answer as a decimal. So here's my equation. Here's my a, my b, and my c that I substitute into the quadratic formula. I need my t squared term first, then my t term, then my constant in order to do that. I get two x values, a negative and a positive, and then I'm going to explain them. So the x-intercepts represent when the ball is on the ground at 0 meters off the ground, which is at a negative time, not possible, so we can ignore that and just look at the 6.8 seconds. The y-intercept represents the height of the ball of 1 meter at 0 seconds, so most likely when someone's holding the ball up before they shoot it. The ball problem, again, this time I'm going to find the vertex by hand. So I'm going to use the formula negative b over 2a to represent the vertex. I'm going to substitute my value for b and my value for a into this equation and solve for the vertex. When I know the x value of the vertex, I have to then substitute the x value into the equation for the x's and solve for the y. So my vertex is at 3.2, 4.6. And then I'm going to graph it by hand now that I know the x-intercept, the y-intercept, and the vertex, and I'll get a graph that looks roughly like this. You can substitute other x values into the equation, and then you can find their y values to get a more accurate curve. I'm going to explain the vertex. So the vertex shows the maximum height of the ball. So at 4.6 meters and at 3.2 seconds is the height of the ball. Last question, Lily is selling lemonade. She needs to make a certain amount to get a profit. So I'm going to find the y-intercept by hand with substitution. I'm going to find the x-intercepts using the quadratic formula, just like the last problem. And then I'm going to explain it in the context of the problem. So you can see that the y-intercept shows a loss of 17 euros if 0 cups are made. And the x-intercept show a profit of €0 or breaking even if she sells that many number of cups.